Next up, our featured presentation. We're gonna hear from Andy Fleener, and I'm excited about Andy getting a chance to speak to you here. Some of you may have seen him speak at Devops Days Minneapolis in the past, and exciting news that I'm not even sure if it's on the website, but people probably don't obsessively check the organizer list for the Devops Days Minneapolis website. But Andy has actually joined the team, so he's going to be running around this year, helping with registration and helping make sure everything goes smoothly, which you want it to at the conference. By the way, I want a quick show of hands. Is there anybody here who is actually attending, has their ticket, and is going to be at Devops Days Minneapolis? Hey, look at that. We actually have half a dozen people.
Yeah.
Well, because sometimes it's all like, no. It's like, okay, you're going to be sad. Anyway, so I think the reason I'm the most excited about Andy giving this talk is I asked him to give this. He was willing to give it at another time for another event, and I was like, but Andy, I want that talk for our meetup.
Yes.
And he brought it here, and I'm really excited.
Yeah.
So without further ado.
Yeah, the funny thing about submitting a talk is there's no actual guarantee that you'll ever have to write it. But then when you have to write it, it's so much more work than writing a paragraph to submit a CFP. But I'm actually really glad I wrote this talk because I learned some things about circuit breakers that I hadn't really thought about because I was sort of forced to think about them. So this is the shocking truth about circuit breakers. So show of hands, who knows what the hell that actually is? Cool. About a third of the room? All right. So you're gonna learn some interesting things. I'm super interested in resilience, but I work for a company you might have heard of, SportsEngine. We use circuit breakers within I'm the platform operations manager at SportsEngine, and we use circuit breakers within our technology stack. And this talk is really about that sort of story of actually using them. We've only been using them, well, first, what the fuck actually is a circuit breaker? We'll get to that. There are a few things I want to talk about first, which is why I'm glad you asked. So before we talk about circuit breakers, let me get to the point about resilience. So how many people remember the S3 outage that happened, let's see when I tweeted about it, sometime in March? Yeah, that probably affected some people. Yeah, cool. So remember when they were human error was the thing that caused that, and it was because somebody fat-fingered a command line argument that caused that entire outage? Yeah, I'm here to tell you that's bullshit, which is what I was tweeting about immediately following is highly reliable systems tend to fail catastrophically. Resiliency comes from finding ways to add capacity to fail. So a circuit breaker is a concept that is adding capacity to fail. And might not be, but I'm an optimist that we can actually do this. I think this is where we're going as an industry. I think this is how we make improvements. So important story is network latency is a distributed systems kryptonite because physics. There is no way to have an instantaneous request, right? There's an amount of time it takes to for the electrons to move through and actually make that. But the circuit breaker is really the lead box that contains that kryptonite, right? Superman has no way to defeat kryptonite other than for it to end up in a lead box and then it doesn't affect him. So here we go. Here's the definition of what a circuit breaker is. Martin Fowler, who's pretty into this kind of stuff and well-respected expert, sort of describes a circuit breaker with this chart. So if you look at this chart, you've got a client. In between a client and a supplier, so anytime you make an HTTP request, you put a circuit breaker in the middle. And what in the middle means is you wrap the actual code that's making a call to some sort of remote host. And that just happens. Most of the time it's fine. Network is generally reliable. TCP is generally reliable. Except when there's a connection problem. When there's a connection problem, you get a timeout. Pretty normal stuff. We all understand what timeouts are for. But what happens when you get sequential timeouts, and then another timeout, and then another timeout? And now your request pool is starting to fill up, and then you see those dreaded shark fins showing up on your graph. So the general idea of a circuit breaker is that protection that prevents that from cascading further. This pattern was first implemented, or first sort of named by Michael Nygaard in his book Release It back in 2007. That's right, that's 10 years ago. This has been around for 10 years. It's implemented in many different languages, and it exists, and there are people using it. Cool user story, bro. So like, yeah, let's just go out and let's do that. We'll just implement that thing, and then like we've got the resilience and the magical dust, and we're good to go. It's like not quite that simple, but so I'm thinking you're probably thinking one of three things right now. Like I'm telling you about this awesome thing that you should probably be using, right? So yeah, I'm just gonna go out and I'm actually gonna implement all of these circuit breakers and start using them. Cool, all right. Or you're thinking, my network is reliable and I'm totally fine. Like, all right, that's fine, you can think that. The other thing is like, was that a Mr. Robot GIF at the very beginning? What are we talking about? So, those are all perfectly valid thoughts. But I'm here to tell you it's not quite that simple of doing any of those things. I mean, yes, it was a Mr. Robot GIF to answer that question. But like, at SportsEngine, we started using circuit breakers a year ago. Actually, it was slightly over a year ago. The first implementation, I think, went into production somewhere in February of 2016. We're still trying to figure it out. Literally, there is a story on our board that's investigating what's happening with our circuit breakers, like this sprint, okay? So like, we're still trying to work out these problems. Like, we're still trying to understand how to use this most effectively. But it's been out for 10 years. Like, why aren't we all using this? Like, it's a decade. What were you doing for the other 9 years? Okay, so what I was doing was learning a lot of hard lessons about complex systems. Who all operates a complex system? Yeah, everyone in this room, in some fashion, operates a complex system. So complex systems, cliff notes, is that they're unsafe. That's just the state of the world. They will always be unsafe. You cannot do anything to make them safe. Failure is inevitable. Embrace the failure. That last part is super important. So we started our journey from monolith to microservices back in 2011. So SportsEngine has 23 different services. And this on a status page update was where I got that line about the murder mystery novel in my talk title. And it's absolutely right? Like, microservices are awesome, like, huge fan. But wow, how do you know what was the thing that actually caused the outage if, like, all of the things are then, like, triggering and failing and all of that stuff? So we learned this lesson. This happened to us, right? It quickly became, like, services are dependent on each other. Like, it's just, that's what it is. I mean, like, I don't know how else to describe it. Like, sad server nails this, right? So enter this burning ring of SOA. So you've got this architecture. So we're like 100% on AWS. Okay, 100% on AWS. So say we have this little incident that maybe happened in 2015, where Dynamo gets real sad, right? And then you're like, well, now what? So we got this, like, let me describe this architecture. So we got a user who's trying to use a CMS. The CMS then, like, grabs a widget from the red widget service or a widget from the yellow widget service. And then, like, in order to do that, you have to talk to the authentication service. Those two widget services are backed by Dynamo. Okay, so then, like, one of them starts going like this, and then the other one starts going like this, and then that CMS is like this, and then boom, the user is like that, right? Like, and that's what happens. Like, we know this happens, right? Circuit breakers are your only defense against this. Only defense. So, Hastrix to the rescue. This came out in 2012. These are the things I'm discovering, like what year these things came out in, right? 2012, Adrian Kokarov's like, we released Hastrix. Hastrix is Netflix implementation of the circuit breaker pattern. It's very commonly used, probably the most commonly used circuit breaker tool out there. Boom, we got circuit breakers, let's use them in 2012. Cool. So real talk, it's hard for a systems thinker, so I consider myself a systems thinker. Everything that we do evolves around the systems that we interact with. So I find it hard to communicate with non-systems thinkers. I told Jeff Sussno one time that systems thinking has broken me, and I thanked him for that. But then I was like, now I don't know what to do because, like, I can't stop thinking in systems. So like, what seems like an obvious solution to us doesn't really sound obvious to everyone, right? Like I get this feeling where like I'm like, am I talking crazy? Like I don't know what, like I'm having this issue communicating. So like the hardest part about circuit breakers is explaining like why we actually need them, which is why I made this like great little network diagram that's like cry party, right? So I feel like that's a pretty good use of it. But the most common reason is that like resilience is counterintuitive, right? You have to fail to succeed? Like what are you actually talking about? Like failure actually makes you more successful. You actually serve more traffic because you failed. So what you really have to do is talk in terms of outcomes. Like how many outages happen because this service over here failed, which then caused that service over there to fail, that then caused that service over there to fail. And then all of your customers will call you on the phone and be like, what the fuck? Like we want to be able to use our services. Yeah. So what happens if like only the first service failed? Like how many customers are actually impacted by that? Like what if red widget service was the only thing that was down? Or even if red widget service and yellow widget service were the only things down? Like, so you don't get your widgets, but like there's all of these other features of a CMS that you might actually get, right? And so you have this like this sort of like partial degraded performance, but their ability to view a website that is already there, or like to edit some other thing that's not related to the widget service is totally fine. Cool. So let's fail on purpose. Now what? So when you decide to use circuit breakers, you got to think about a few different things. You obviously can't implement a circuit breaker with every possible use case. Like it just doesn't make business sense. So like organize it by impact. Like where is the central location that then if you add a circuit breaker to that, it will then make a huge impact throughout your platform, right? So the other key thing, and I had to explain this so many times. A circuit breaker is only useful at the service level. You cannot pick and choose what you want to put a circuit breaker around, because then when the thing is slow, like you're still getting requests through and it's still queuing up the service that has the circuit breaker. It's just not queuing up all of the requests, but it's not effective if it's not the entire service, right? And then like use an abstraction. Please use an abstraction. Make it easy to use, so that your developer, like the whole development organization, just rallies behind the fact that like they want to use this. If it's not easy, no one will use it. No one will use it. So build it in. Build it in. Like, I mean, like Hastrix is a classic example of like building this thing that then you just get for free as soon as you start trying to use it, right? Like Netflix is all about this model of just making the right thing the easy thing, and that's how you solve these problems. You make the right thing the easy thing. Sweet. So what does that look like? All right, I'm going to do a demo, and we'll see how this goes. And I burned through those slides super fast. All right. Oops.
You have plenty of time to screw up the demo.
That's right. I know. I'm pretty excited for that. So why is there an Apple thing? Okay. So I made this repo. It's there. If you want to check it out. This is a Rails app using a circuit breaker. So concept is there's all of these tooling around like being able to simulate what slow network traffic looks like. One of my favorites is called Comcast. I work for SportsEngine. We're an NBC company. NBC's owned by Comcast. One of my favorite ones is called Comcast, and it's about shitty internet connections. So the other one that I'm actually using for this demo is ToxyProxy. It's put out by Shopify, and it's pretty great. It has like a ton of awesome options. Key problem with Comcast is that you can only slow down inbound network traffic, which isn't super useful when I'm trying to do it on my laptop. So, ToxyProxy to the rescue. Basic concept, install it, run the server. Nobody can read that because it's really small. Is that slightly better? So then you verify that it's there, you start up your Rails app, you make a request. So the other thing that I super love is health checks. At SportsEngine, we have this super awesome Ruby gem that we wrote that basically is the end-all be-all for what a health check looks like in a Rails app. It's called OK Computer. So it's inspired by one that existed prior that was called Fitter Happier. And we took it and just sort of ran with it and started building health checks for all kinds of stuff. And it's got this like simple interface for like verifying that like something is working. And so what I did was built an OK Computer check that like makes a request to Toxie proxy, which hits Google to then verify that I can hit Google, right? So like really what I'm doing is testing that Google is available. And Toxie proxy is the thing in the middle that I'm gonna tweak and slow down such that the circuit breaker trips. So let's start this out. So I've got this app, and so all of its health checks are here. There's one. It's called circuit breaker test. Nobody can read that. Boom. All right. So it's here. It's making an HTTP check. It was successful. It took 1 second through the proxy, right? So over here, I've got the proxy server running. These are the requests that are coming through the proxy server. This is the Rails app. It's running just on my computer. And then over here is where I'm gonna slow down some traffic. So I'm making, this is just me making a request through the proxy, and it's working. Let's see how this looks. All right. So then when I want to slow it down, this is why I wrote this in the README, so that I wouldn't have to write it. Nope, I already did that. Nice, there it is. So I'm going to add, so what these options are is I'm going to add a toxic to this proxy that I set up on that port. It's going to add latency of basically 10 seconds. Boom. So then now, when I make my curl request, it takes 10 seconds. All right. So when I go back over here to this Rails app, when I do this, it's going to time out. I set a timeout at 3 seconds, and so it times out. It only takes 3 seconds. All right, so timeouts work. That's good. Secondarily, if I make subsequent requests and they time out to the point that I hit my threshold, it's then going to trip the circuit, which I have to make 3 of them before that actually happens. And we'll see if that actually works. Maybe there it is. So, failed, error, refusing to run code while circuit breaker to google.com is open. So this is what happens when you make that 4th request. It's like, nope, not going to do that. Going to keep your server running, or keep your server up instead of like doing this thing that I know isn't working. All right, so it's not going to be able to do anything right away. And it's going to, if I make, so this is a subsequent request that I made while it's still slow. So this is what's called the half-open timeout. So there's a TTL that basically is like, after this amount of time, I'm going to attempt to make another request at a much lower timeout and see if it'll be able to like make that request successfully. If it's not, I'm just going to be like, well, I didn't do that fast enough. But there we go. I'm just going to flop it back open, and then there's no power, right? So back open, failed request. So if I disable this actual toxic, which is this code, then when I make this request and it expired, why did it expire? Probably because I set my timeout too low. Come on. Damn it. It totally worked every time I tested it. Oh, other thing is that every time the circuit, so I wrote this code in a way that every time the circuit opens, it's just printing that it opened. But what we actually use that for at SportsEngine is we'll trigger a PagerDuty alert and be like, circuits are open. We should be paying attention to what's going on because that's not supposed to happen and it's happening. Maybe one more time. Damn it. So let's see. Maybe if I restart this Rails server, it'll just work. Damn it. Well, let's see if I edit the timeout so that it's different. Of course this is happening. I seriously tested this like 20 times earlier today. So retry timeout. Ha 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 ha. Half open timeout. Let's go with a second instead. I'll show you this code in a second. This works on my machine, bro. That's what we're doing right now. Except that it doesn't.
SPS networks too fast.
Oh, I'm not on SPS's network. Boom, there it goes. All right, so it was my half-open timeout was slightly aggressive because my laptop is not fast enough to respond in 100 milliseconds. This time, when it was earlier. Okay, so there's the demo. This is what the key important code looks like, right? So got all these gems. These are gems that we use at SportsEngine to sort of do this, right? So we're a Ruby shop. We have a bunch of Rails apps. We have some Node apps as well. But the key places that we've implemented this with our sort of back-end, like data-driven services is our Rails apps. So there's this breaker, this other thing, and stuff maybe you should care less about. But then the actual code looks like this. So this is our OK Computer configuration. We're setting up the sort of the breaker and then like where it stores data. So there's this sort of in-memory. Make it bigger. All right. This in-memory repo that then like holds the information about the circuits, and then they update, right? So it's sort of data-driven. So like as you make subsequent failed requests, it updates that there's more failed requests. When the circuit opens, it alerts that the circuit opened by putting a message to the console. When it closes, it alerts that. That would be there, right? So it happened way down there. And then this is the HTTP check that I wrote specifically for this use case that defines a proxy and then a host and then makes a Ruby request wrapped by this circuit. So this circuit is sort of the key information here. So after three seconds, timeout. After 3 failures, open the circuit. Only keep track of failures for an extended period of 60 seconds. And then after 10 seconds, attempt the actual half open, which then has that half open timeout of 100 milliseconds. So like what you can see this is doing, right, is it's sort of delaying the inevitable. You're putting off like all of these failed requests so that you're only making a few of them. Like the half open timeout is all about just making one to see if it's available to service back up again. And like you want to test that like sort of frequently. You don't want to just like assume that the service is down for an extended period of time. You just want to kind of ping it, let it tell you if it's back up or not. But you want to be more aggressive about not allowing traffic there. So you set a more aggressive timeout so that you know if it's come back or not. You're already like not trusting what that service is doing. So you're setting a more aggressive timeout to tell you. And then this is registering an OK Computer check is this last line. Cool. So back to this display. So sort of key things to think about here, right? Find a library that was implemented for a language that you care about, obviously. Don't assume it's going to work. Not everyone understands the key essential pieces to what a circuit breaker needs to be. If it does not have a timeout built into it, it's not going to solve your problem. Like, the timeout is the essential part of how this works, because it's all about network latency, and if it's not thinking about that, then it's really not been tested in a way that you can be sure it's meaningful. But you definitely need to assume, unless it's something like Hastrix that you know Netflix is using in production, that you're going to need to test this and understand like how it works at its lowest level. And the only way to do that is to test it. Use these libraries that will like slow down network traffic for you, play with the network, do those sorts of things. But timeouts have to be a primitive of the actual circuit breaker. So there's a few, I kind of mentioned them, right? So Comcast, Toxie Proxy, in a pinch IP tables and TCE, which is really what Comcast does, can be used. If you're super familiar with IP tables and how to use it, go for it. Worst case, use some sleeps. It's like the dumbest solution to the problem. And you won't be able to get your circuit to close again, but like, at least you've tested that it will open when you want it to, right? It kind of sort of solves the problem. But yeah, that's about all I got. If there's any questions, I'll be happy to take those now, I guess. What season is Mr. Robot in? They finished the second. The third one will start sometime at the end of the year. My Twitter brand is definitely mostly Mr. Robot gifts, so like, you got to keep on brand, you know. Yes.
What happened a year ago?
Ha! Good question. So
Can you repeat the question?
the question was, what happened a year ago that triggered this, which obviously was a thing, right? I mean, like, what makes your organization actually care about this? It's usually some sort of outage that's like, that was a real problem, we could have prevented this, and you kind of have to just keep being like, we could have prevented this, we could have prevented this, we could have prevented this. The key one that really started us on our path was the Dynamo outage from 2015. So that was like in September of 2015. What happened was I'm pretty sure it was Netflix, started using this secondary index thing that they were like not ready for a bunch of people to use, and just ruined Dynamo for everyone. And it just was classic network latency problem, right? Like, it was available because the metadata service that was involved in it was not very responsive. All of the requests took forever. And so it was just classic, like, slow network problem. At the time we implemented our own, like, sort of stupid circuit breaker, and we just turned off the service that actually used Dynamo. And it failed fast, and that was the end of the problem. So that can be used in a pinch also, but yeah, that was really the thing that drove it for us.
Sorry, point of order really quick. I'm going to make sure a mic goes to that person so the question ends up on the video.
Yeah, thanks. So in your demo and the other things you've talked about, it seems exclusively driven by poor latency, like
Yes.
request did not resolve. Is that true? Are there other types of circuit breakers? I mean, you talked about maybe having a passion for other types of health checks. So have you implemented or have you heard of libraries that are really circuit breakers looking for other types of application misbehavior?
Yeah, I mean, there totally are. So there's a whole field of so Google wrote the SRE book. I assume people are familiar with that, right? So Site Reliability Engineer is a title which I'm sure some of you in this room have. And what that's really about is like ensuring that your business can function because your services are available, right? There's this other title that I've been thinking about a lot that seems like more impactful, and that's Resiliency Engineer, and that's about like assuming things are going to fail and then sort of like reacting. What I think you were getting at is I talked briefly about like adding capacity to fail. So circuit breaker is a way to add capacity to fail. So like the system is failing, so you're sort of absorbing it and like continuing to move on. There's other patterns. One of them being that my team was talking about earlier this week was the like bulkhead pattern, about like only allowing a certain number of requests to a service before you stop doing that anymore. So you sort of like a ticketing system, right, where you make a request, and they're like sort of hanging there. Maybe they will eventually resolve, but like it might not be related to network latency. It might be something else. Yes, exactly. So yeah, funny thing about OK Computer is we do lots of things with it.
Sorry, can you repeat the thing that he said?
So yes, I can. The question was, would that also involve like monitoring a queue? Queues are a classic problem with like sort of like having a way to solve the problem, but like they're a problem immediately, and then you have to solve the problem because once they overflow, you're having issues. And monitoring a queue is super easy. You just check the size of the queue, and if it like isn't going down, then you got a problem. So we've handled that in a few different ways. Like general just size checks. You're like, if it's over this number of items in the queue, alert, and like we should be able to sort of resolve that in some fashion. There's like more complex ways to do that by like understanding if the sort of rate of change has changed. And you can do that, but you have to have memory in the health check. These are all about like HTTP health checks. You make a request, it answers the question, and then you're done. Some of those things are a little bit harder. You have to keep state somewhere, and then you're like thinking about whether the thing that I'm keeping state in is going to be available. Lots of interesting questions when you're thinking about like what is actually working versus like assuming everything is working though. Does that answer your question?
Yeah.
Okay.
If you're using AWS, do you need to implement a circuit breaker?
Yes, absolutely. In fact, I would argue if you're using AWS, you most definitely always need to implement a circuit breaker because AWS is not reliable at all. It is, but then it's also not. Servers die, like the cloud is just generally like things fail. And I think that really kind of drove the desire to like build in this resilience, right? Like Netflix started doing this stuff after they decided they were going to move everything to AWS.
But I mean, editorial, observation. You really think your data center is perfect either?
Right. I mean, yeah, they're valid.
We have been using circuit breakers for many years now, and then some cases where some strategies that we have shown, like sequential failures and static timeouts, eventually where we ended up is those things were too difficult to configure when there are mini services. We have about 600. So,
that's a lot.
So what we ended up doing is moving to a rate of failure for thresholds versus moving bell curve based timeouts. Did you run into that kind of a situation anywhere? And then I know we have cooked our own implementation for that because we didn't find something.
Yeah, it's hard to. So like one of the things that I like sort of brushed over is when I was showing that demo, you have to keep state somewhere. We made a decision to keep state in a central location. So we have an app pool of, let's say like 15 AWS instances or something. And they're all using that same central state location such that like if that it's memcache. So say if that was unavailable, like then that would be a problem. But we made that trade-off because we wanted it to be central such that like if this other service is being shitty, like we're gonna assume that not everything is falling apart. Because if everything is falling apart, like you got problems, and it's mostly worked for us. I'm not sure. You're absolutely right, though. Like configuring 600 services for deciding what is a valid timeout for 600 services would be really hard. We did a lot of thinking when we set timeouts and like failure counts, and there's not like an end-all be-all solution to that problem. It really depends on your service needs and like what they're doing. Which is a classic no answer, that it's just more complicated, it depends.
I mean, I think when you're going to it depends, maybe a valuable thing to think about would be your business needs.
Yes, absolutely.
Like,
that's always a valuable thing to think about.
Like the stuff that matters is probably the stuff that costs or makes you money.
Yes, right. And that was sort of what I was trying to get at when I was talking about like prioritize on impact. Impact could be the thing that's in them. So like the way I would describe our sort of infrastructure is that we have this sort of centralized monolith that is the sun, and then like a bunch of microservices that like revolve around it. And we're sort of breaking pieces out of that monolith, right? Like it's happened over a long period of time. It's continuing to happen. And so what we deemed most important was that monolith, and that was really where we focused on like adding those circuit breakers and sort of preventing that from like catastrophically failing because one of this random other service failed over here. So it's all about impact. You really have to think about impact.
All right, awesome. Do we have any more questions for Andy? It's a lot of really great questions.
Yeah.
I suspect people are gonna yes.
I have one quick one.
Ooh.
Do you think in implementing circuit breakers, so I think one of the things that becomes interesting as your systems get more complex and as you go from monolith to microservices, some of the challenges in that are where is the problem? Mm-hmm. So in the process of implementing circuit breakers, was there anything you did to help improve the visibility or observability of your system in a way that made it easier for you to identify the root cause along the way, or was it more about just simply managing failure?
Yeah, so I think, you're absolutely right. Like I didn't particularly answer that question when I was sort of like proposing it to myself. But I think it's sort of twofold. Like one, you're getting more observability because so key thing, like make a circuit around a specific service, right? Like don't make one service or one circuit for multiple services because like that's not like how it's supposed to work, right? Like it's just for a single service. But then like make that flag, that alert, that whatever it is that raises to like tell you what service is misbehaving. Hopefully you've got some other monitoring, some APM that's going to tell you that stuff too. But in reality, like that circuit going off is like that thing over there is not doing what it's supposed to do because like I've defined this as the valid response for that thing, and it's not doing that, and it's not meeting that promise. But secondarily, like I mean, you really like adding more observability isn't going to hurt you. Like you want that for sure.
You preaching charity majors' gospel, right?
Yeah, that word like just is super meaningful to me. Like I hadn't heard that until like this year because charity has been super preachy about the word observability, and that is the best way to describe what we're trying to do. Like monitoring is not what we're trying to do. We're trying to observe what's happening, and that's the only way to sort of handle complex systems.
Yeah. We have more questions.
Oh, more questions. All right.
All right. Well, we'll take you and then you.
I just wanted to comment. Yeah, absolutely. So in addition to adding more observability, I think as you're implementing circuit breakers, you're like in the code, right? Like looking at what's going on. That's when it's the best time to like, you're like, oh, this key transaction like could really use additional logging. And that's when you can like wrap things that are important also in more logging for more observability. Yeah. So.
Zach, with your manager up there speaking, I feel like this is a great time to ask a really complicated question too.
He would too.
I'll pass for right now.
Yeah. All right.
Yeah, so in your examples that a circuit breaker is open and an alert is triggered, have you done anything to take it a step further and have like an automated recovery response at all? Or do you just say, hey, we got to alert the humans that the machines have gone off the rails in one way or another?
I mean, so that's a good question. I think the hard part is defining what automated recovery is, right? Because like I don't know what that is. Like I tend to like look at a problem. I mean, there might like in some situations that might be a thing that exists. Like you might restart something. Sure, yeah, like. Sure, I mean like that is a solution to something, but like network latency tends not to be the solution. It's like usually it's like AWS is having like routing problems, and you're like I don't really know what to do because it's AWS's problem, but at least I know there's a problem, and I can tell all of my customers that I'm having a problem.
So you haven't actually tried just rebooting your network?
I'm just gonna like rerun that classification
Didn't
template.
AWS try that? It didn't go so well. That was February.
That was 6 hours. We were back online. It's fine.
Oh man.
Great.
Horror stories.
Fantastic. Okay, so I'm gonna call it here just to give everyone a chance to come up and have individual conversations, which I know.